Welcome back to my YouTube channel. Myself, I am Lokita GS, studying in Sri Venkateshwara College of Engineering, Bengaluru, in the second year of third sem. Today's subject, which I am going to discuss, is Digital Design and Computer Organization. The subject code is BCS 302. In this, the topic which I am going to discuss is interrupts. Topic to be covered are introduction to interrupts, types of interrupts, interrupt handling process, interrupt vector table, interrupt prioritization, interrupt latency, interrupt masking, interrupt driven input output, interrupt handling overhead. Conclusion. Introduction to interrupts. Interrupts are an essential concept in digital design and computer organization. An interrupt is a signal that causes the CPU to temporarily suspend its current execution and handle a specific event or task. Interrupts helps in managing multiple processes and handling time sensitive events efficiently. Types of interrupts: hardware interrupts, software interrupts, expectations. First one, hardware interrupts generated externally by devices such as keyboard, timer, or input output devices to request attention from the CPU. Generated internally by the program or operating system to intimate a specific function or service. Generated when the CPU encounters an error condition or an unusual situation. Interrupt handling process. When an interrupt occurs, the CPU saves the current state, including the program counter and register, to resume execution later. The interrupt handler, also called an interrupt service routine, is then involved to handle the interrupt. After handling the interrupt, the CPU restores the saved state and resumes the interrupt program. Interrupt vector table. An interrupt vector table is a data structure that holds the address of interrupt handlers for different interrupt types. Each interrupt type has an unique number of code associated with it, known as the interrupt vector. The CPU uses the interrupt vector to locate the appropriate interrupt handler in the interrupt vector table. Interrupt prioritization. Interrupt can be different priorities to ensure that critical events are handled first. Priority levels are assigned to interrupt, with an higher priority interrupts taking precedence over lower priority ones. Interrupt prioritization is crucial for the real time system to ensure timely response to the time sensitive events. Interrupt latency refers to the time it takes for CPU to respond to an interrupt. It includes the time taken to save the current state, locate the interrupt handler, execute the handler, and restore the saved state. Minimizing interrupt latency is important in time crucial application to ensure promote handling of the events. Interrupt masking is the process of temporarily disabling interrupts to prevent their immediate execution. It is useful when handling critical sections of the code or when certain conditions need to be met before an interrupt can be processed. After the critical section is completed or the conditions are met, interrupts are unmasked to resume their normal operations. Interrupt driven input and output. Interrupt plays a critical role in handling input and output operations in a computer system. Instead of continuously polling for data, the CPU can be restored when data is available for processing. This approach offloads the CPU from the constantly checking for the input and allows it to perform other tasks until an interrupt occurs. Interrupt handling overhead introduces overhead due to an additional operation required to save and restore the CPU state. The interrupt handler itself also adds overhead as it needs to execute before the interrupted program can resume. Optimizing inter- interrupt handling is important to minimize the impact on overall system performance. Conclusion. Interrupts are fundamental aspects of digital design and computer organization. They are enable efficient handling of events, prioritize critical tasks, and facilitate interrupt driven input output. Understand interrupt mechanism and optimize their usage is critical for their designing high performance computer system. Interrupts are classified into two types: hardware interrupts and software interrupts. Hardware interrupts are further classified into external or input output interrupts and internal interrupts. Expectations generated by an input output subsystem to communicate successfully completion of input output ready state of interrupt driven input output and error in input output. Internal interrupts, a malfunctioning detected by the CPU hardware, generates interrupt driven divided and overflow, arithmetic errors, invalid instructions, address, range error, etc. Condition set in hardware. Page fault is not an error but a method to replace page in virtual memory concept. Debug mode of operations of program caused an interrupt. And software interrupts are classified into program generated by the user's programs using int instructions useful for the system calls. This feature is required while writing the device drivers. Thank you.